Hello. In this video, we're going to continue our study of identities, and we're going to use some of these new identities to prove other identities. So here we have something cos of theta minus pi over 2 equals sine theta. So this is an identity question. We would like to prove this. That means we have to do some algebra on the left and the right and work it out to show that the left-hand side equals the right-hand side. Now, the left-hand side, it's sine theta. What are you going to do to it? There's really no work to be done on the right side. But the left side, it has this theta minus pi over 2. This looks like that sort of alpha minus beta business. And if you remember, there's an identity. It says that cos of alpha minus beta is equal to cos alpha cos beta plus, remember cos is the weird one. If you look at the formula sheet, the minus turns into a plus, minus sine alpha sine beta. So if we notice that alpha is theta and beta is pi over 2, we can go ahead and use that identity. So we'll get cos theta cos pi over 2 plus sine theta sine pi over 2. Now you might say, well, that's way more complicated than what we started with. And sure, maybe it looks like that initially, but cos of pi over 2 is a unit circle value. So this is going to be 0. And sine of pi over 2 is a unit circle value. That's going to be 1. 0 times anything is 0, and 1 times anything is 1. So we just have sine theta. And so the left-hand side equals the right-hand side. Fantastic. So we're going to look at a number of identities in this video, and I kind of like this one. It says that sine of 2 theta, or in this case sine of 2x, divided by cos of 2x plus sine squared x equals 2 tan theta. Now, if you look at your list of identities, there are some other identities that we haven't mentioned yet, but now's a good time to go ahead and highlight them. One of them is that sine of 2 alpha is equal to 2 sine alpha cos alpha. Or you could have theta, or you could have x, really any angle you want. And this identity is all about if you have a 2 inside. Now, if you look here, we clearly do have a 2. So that's going to be a great identity to apply to the top. 2 sine x cos x. Now on the bottom, things get a little trickier. We have another 2, a cos 2x. And if you look at the formula sheet, there's actually 3 options for cos of 2 alpha. Well, let's take a look. Cos squared alpha minus sine squared alpha. 1 minus 2 sine squared alpha. And 2 cos squared alpha minus 1. So the nice thing for that sine one is there's really only a single option. There's only a single option, and so if you see sine of 2x, just put 2 sine x cos x. But here, unfortunately, we have 3 options. And so like most identity questions, how do you know which option to choose? You don't. You just gotta try one, and if it doesn't work, you try another one. So in the spirit of trying something, let's go ahead and just try that first one. Might as well. So that's going to give us, instead of cos 2x, we're going to get cos squared x minus sine squared x plus sine squared x. Well, these two cancel, so that's kind of nice. Gives us 2 sine x cos x divided by cos squared x. Now, because everything's multiplied, we can think of cos squared x as like a cos x times cos x. And I'm going to write that as cos x times cos x because I want to cancel one of those cos x. So I have 2 sine x over cos x. Well, tan, if you remember, is sine x over cos x. And look at that. The left-hand side equals the right-hand side. Now, in case you're wondering about these identities that we have, these formulas, they're kind of interesting, and I want to talk about them just briefly. So if you watched the video on the sine alpha plus beta business, we can look geometrically to see proofs of these identities. So we get our sine alpha cos beta plus cos alpha sine beta. And assuming you watch that video, or just assuming you take this on face value, we can use this formula to prove the other formula. Here's how it works. Sine of 2 alpha is kind of like, well, if you have 2 apples, you have an apple plus another apple. And so what we do is we use this formula right here, except everywhere we see an alpha and a beta, we just put alpha and more alpha. So we get sine alpha cos alpha plus cos alpha sine alpha, right? We use formulas to prove new formulas. Well, sine cos is the same as cos sine, so we have 2 sine alpha cos alphas. And that shows that this equals this. And so, yeah, that formula is definitely correct. It's a legitimate formula, and it's kind of cool, kind of neat to see where it comes from. If you were curious about the cos 2 alpha formula, we could do cos alpha plus alpha. And then we would just use our cos formula on the alpha alpha. So if you remember, it's cos alpha cos beta, but it's not a beta, it's just an alpha and more alpha. And then we get minus sine alpha again. So that's cos squared alpha minus sine squared alpha. And that shows you that at least first option on the formula sheet. Now, for fun, if you wanted to, you could try to see how you get from there to cos squared alpha minus 1. Or even if you were really curious, you could go to the 1 minus 2 sine squared alpha. Now again, maybe it's good enough for you to just see that, hey, they're on the formula sheet. Mr. Peters wouldn't put them on the formula sheet if they weren't true. And I mean, yeah, that's a good idea. I'm glad that you guys trust me and trust the formula sheets and ultimately trust the province of Manitoba to put down the right formulas. But it is nice to have a justification for where these formulas come from. All right, so we've got another one here. Tan squared x plus 2 cos squared x equals secant squared x plus cos of 2x. So go ahead and pause the video and give this one a try. All right. Well, that cos 2x, I think I need to convert that because notice everything else is x, x, x. The 2x definitely needs to go. So I'm going to do, I'll just do the usual one, cos squared x minus sine squared x. I'll try that first option again. Worked well for me last time. And secant is 1 over cos, so 1 over cos squared. Now over here I have this as sine squared over cos squared plus 2 cos squared x. And I'm thinking a common denominator might be a good idea here. So this is over 1. So let's multiply by cos squared. Cos squared. It's going to give me sine squared x plus 2 cos to the 4x all over cos squared x. Well, if I'm going to common denominator there, I should probably common denominator over here. This one needs a cos squared, and this one needs a cos squared. So that'll give me 1 plus cos to the 4x minus sine squared x cos squared x over cos squared x. Now, I mean, this is kind of like medium, right? If we look, here's 2 cos to the 4, and here's a single cos to the 4. That's not quite the same. We've got an extra 1 here, and there's no 1 on top, and there's this kind of business here, but what I might suggest is there is a sine squared, and there's a sine squared here. So maybe what we could do is we could take this cos squared and convert it into a sine squared? But that might make too many sines. Maybe we could take this sine squared and convert it into a cos squared. Then we're gonna have a lot of coses. Again, when you get to a situation like this, it's sometimes not clear what you should do. And so here we just have to try something. There's not a clear path forward, but if we end up stuck, we can always backtrack and try again. So let's do this as 1 minus cos squared x. Here we've got cos squared x, 1 plus cos to the 4x over cos squared x. Now if I multiply that out, I get 1 plus cos to the 4x minus cos squared x plus cos to the 4x all over cos squared x. Oh, this is looking promising. Let's keep working. So now I've got cos to the 4, so that's 2 cos to the 4x plus 1 minus cos squared x over cos squared x. Oh, and if we remember, right, we can use that identity here on sine. So sine squared is 1 minus cos squared. 1 minus cos squared plus 2 cos to the 4x over cos squared. Okay, so now I just write it in the proper order. 2 cos to the 4x plus 1 minus cos squared x over cos squared x. All right, left-hand side equals right-hand side. And just as a word of advice, it's almost impossible to, in some ways, like make a mistake on an identity and still get the right answer. Generally, like if you get to the end and you have the same on the left and the right, you probably did it right. And so if you have two different things on either side, it means that you got to do more work, or it means that maybe you made a mistake earlier. But if you get to the end and you have the left-hand side equals the right-hand side, even if you did it a bit differently, you'll be fine. There's more than one way to do these questions, and I'll be watching for that when I mark. You'll definitely get full marks as long as you follow the basic steps, you use formulas from the formula sheet, don't break any rules of algebra. And I find it quite satisfying in the end. When you finally get that left-hand side equal to the right-hand side, even if you did it a bit different from your friend, you know that you have the correct answer. And you should feel really satisfied with yourself when you get there. Now here's another one. Again, I'd encourage you to pause the video and give it a try. That sine to the 4x might be a bit tricky for you, but I'll give you a hint. You could think of sine to the 4x as sine of 2 times 2x. All right, that's my hint. Give it a pause and try it out. All right, so just continuing with my hint, what we have here is kind of like a sine 2 alpha, but the alpha is itself 2x. So the formula then becomes 2 sine 2x, and then cos 2x. All right, so let's go ahead and pop that in over here. 2 sine 2x cos 2x divided by cos 2x. And we see a cos 2x in common, so we can cross those off. 2 sine 2x. Well, I mean, since that identity worked so well the last time, let's use it again. So we get 2, and then we're using the identity right here on this stuff. So that gives us 2 sine x cos x. Now we got 2 2's. 2 times 2 is 4. And what do you know? That left-hand side equals the right-hand side. All right, here's another one. We have cos theta minus sine theta over cos theta plus sine theta equals secant 2 theta minus tan 2 theta. This one's pretty tricky. I definitely would encourage you to try a couple things. And just as a bit of a hint, on the left-hand side, we might have to use the conjugate. So pause the video and give it a try. All right, so let's work on the right-hand side first. We have 1 over cos 2 theta minus sine 2 theta over cos 2 theta. That's what tan means. Tan means sine over cos, so if it's a 2 theta, it goes in the top and bottom. Now this is nice, we can just common denominator these two. So that feels like we're making progress. Sine 2 theta has got that 2 sine theta cos theta business. Alright, cos 2 theta, let's use that first one, cos squared theta minus sine squared theta. Now that's a lot of work on that right hand side, and the good news is that it looks kind of nice. I mean, it doesn't totally look like the other side, but at least it's one fraction instead of 2. And all the 2 thetas are gone. We just have regular thetas. So that's good news. But what's this hint about the conjugate? Well, our fraction that we have, unfortunately, doesn't have any squareds. We've just got cos theta minus sine theta over cos theta plus sine theta. And so you can't convert the coses into sines. There's really nothing to do. You can't split it because the denominator has 2 terms. It's kind of a mess. But if I multiply both the top and the bottom by cos theta minus sine theta, something interesting will happen. Now, this right here is the conjugate, because the conjugate is from that idea if you had 1 over 3 plus root 5. To rationalize, you multiply the top and the bottom by 3 minus root 5. Right? You take that, the 2 terms, you take the sign in the middle and you flip it. So if it's positive, it becomes negative. If it's negative, it becomes positive. And you multiply in the top and the bottom. So use the same idea over here with trig functions. And I'll show you why. When you multiply it out, you get the following. Cos times cos will be cos squared. Then we get minus cos theta sine theta, working on the top here, minus cos theta sine theta, plus sine squared theta. But the bottom is where the magic happens. The top might be horrible, but the bottom gives you cos squared theta. Then you get cos theta sine theta as a minus. Then cos theta sine theta as a plus. So this minus cos theta sine theta and this plus cos theta sine theta, they always cancel. When you do the conjugate, the middle terms always cancel out. And that's super nice because now what I have here, I mean, it's a mess, but the bottom is the same on both sides. That's super encouraging. Now the top, well, there's a cos theta sine theta and another one, so that makes 2 of them. And then there's this cos squared theta plus sine squared theta. Where have I seen that before? Where have I seen cos squared theta plus sine squared theta? Oh yeah, that's just 1. Look back on your formula sheet, and if you ever see cos squared and sine squared together, right, normally we use that formula to convert one into the other, but this time you have both. So you could just put a 1. Then you got 2. Oh, maybe I'll write it in the other order just so it looks a little nicer. 2 sine theta cos theta divided by cos squared theta minus sine squared theta. Left hand side equals right hand side. Woohoo! We've got it. We've been able to solve our identity. Now we'll go ahead and take some notes on this. Technically, the identities where you have sine 2 theta, they're sometimes called double angle identities. So this is where sine 2 alpha is 2 sine alpha cos alpha. And that one's easy because you only have one option. But cos 2 alpha has 3 options. And so you have to just try one. I do like that first one. I think it's a good one to go to, but there's really no way to know which option is going to be the best. Sometimes more than one will work, but you do have 3 options when you're looking at the cos 2 alpha. Another thing we saw that was kind of weird was if I gave you like sine of 6 theta, you could technically write that as sine of 2 times 3 theta, which would be 2 sine 3 theta cos 3 theta. Something kind of funky, because this right here is your alpha. And of course, that last thing we did, if you had like a 1 over cos theta plus sine theta and you felt like you were stuck because there was no squareds, you could multiply the top and the bottom by the conjugate, which in this place would be cos theta minus sine theta. Now for an example here, let's do 1 over secant squared x equals sine squared x plus cos 2x. So go ahead and pause the video and give that a try. So assuming you gave it a try, 1 over secant is the same as cos squared x. And over here, I'm going to use that first one again. Make this cos squared x minus sine squared x. Sine squared x. These cancel, and I just get cos squared x. So left-hand side equals right-hand side. For practice, we are in unit 7, and you can do worksheet 5. And then any things to remember. One thing I just want to highlight is if you have sine x, please don't write sine theta, or if you have sine theta, please don't write sine x. Stick with whatever variable is given in the question. On a test or on an exam, you'll lose a half mark if you don't use the variable stated, so just watch for that. Alright, hopefully you enjoyed this video, and as always, thanks for watching.